Hi everyone, it's me, Tim. Today I want to continue from yesterday's video about challenges designers face. I want to talk about challenges programmers face, because I've done both design and programming about 50-50. Before I jump in, I apologize, my Nuka-Cola shirt is in the wash. So let's talk about what I think is the single most important personality attribute for programmers in the video game industry to possess. Now you may think, oh, it's intelligence. Oh, it's a broad knowledge of programming, algorithms and data structures, or it's specialization in one of them. No, it is patience. And the reason for that is, if you decide to make video games and you're a programmer, you will be blamed for every single bug in the game. Get used to it. It never will stop. I will even talk about steps I tried to take to make that not happen, and they all failed. But before I get into that, a lot of people think, well, Tim, all bugs are by definition the programmer's fault because it happens in code. No. There's a bunch of ways to make a game buggy that have nothing to do with the code. For example, it is not possible to make code handle every error situation that will ever happen. Let me explain that. There's actually a known thing called the halting problem. I'm a little technical here, which basically states there is no way to make a sufficiently advanced system that as input comes into it can examine that input and say, this input stream I can eventually stop executing. So what that basically means is you can't write a program that examines other programs and says for sure that program can end. It will never get an infinite loop. It will never run forever. And that's called the halting problem. There's no known way of making an algorithm that can detect if a program will eventually stop. You can extend that to, because of that, there's really no way then of knowing that every possible input that can happen to a piece of code can be detected to be error-free. And by the way, even if you can, I'll tell you something that would happen. So that means that there's a ton of ways for artists, scripters, designers to introduce bugs into a game. And we have to extend this to mean more than just crash bugs, but I've seen crash bugs happen because of that. But every single time a bug happens, the programmers are always the first. Hey, the game crashed here. Hey, the game isn't working correctly here. Hey, the game gets really slow here. Figure it out. Now, a lot of times it's not a programmer's fault who did that, but you have to go to a programmer because they have the tools to find it. But even when we try to provide those tools or similar tools outside of programming, many of the other developers won't or don't use them. I'll give you an example. When I was working on a game, there was a problem where it could run out of memory. So we started writing an error message, which would be displayed at the bottom of the screen. It would also go into an error log that would say the game is running low on memory. I mean, this could be a lot of reasons. It could be too many creatures are in the scene. It could be, some textures got imported that were supposed to be no bigger than 2K squared, and for some reason somebody thought a 256K squared texture was okay. Still, programmers would be sought going, the game is running really slow or it crashed here, and they look at the log and they're like, it ran out of memory. Didn't you notice that? I didn't notice that. Or, well, I saw that, but it's not my fault. So even trying to detect a condition and warn them, hey, you've got too much stuff going on here. Figure it out. So it was up to the programmer to go, well, there's a really big texture here, or you're trying to have 200 creatures in this scene, and they all load in all this ancillary art and scripts and associated data, and there's literally just not enough. But there was one time, and this happened on Fallout, where the game ran out of memory so much that I couldn't even create a window to print a string into saying I'm out of memory. I just had to crash. I couldn't even print the string with the memory condition because I couldn't allocate memory to write that string into. The solution to this was when Fallout would start up, it would allocate that error window at startup. But that meant Fallout now ran with slightly less memory than it could have, in the off chance that an error would happen and I'd need to print out the reason. On the off chance that whoever saw that error message would actually pay attention to it, which, as you've seen, sometimes that doesn't happen. Now, this has happened for the entire 40-some years I've been making games. In Fallout, an artist made a sprite, an animated sprite, that was, it was either the size of the entire size of the screen, or maybe even bigger, because something exploded. When that sprite, when the game tried to load that sprite, it had to throw out all the other art to make it work. And if any of that other art was locked, meaning it was literally being used in that scene, you could see it on the screen at that time, it couldn't be thrown out. So depending on when you ran the game, maybe it could throw away enough contiguous blocks because it had to load up in that giant sprite contiguously. Maybe it could find enough contiguous memory to load it. Maybe it couldn't. So that displayed itself as, hey, when you get near this part of the game, sometimes it crashes, sometimes it gets really slow, and sometimes it works fine. Fix it. Well, the bug was, first of all, don't create art that's literally that big. In fact, I think we changed the art tool to warn, hey, you made something and it looks too big. I'll give you one guess at how many artists actually paid attention to the warning messages that art tool made. But this is a good example of, at some point, the artist put it in. The game was working. They put in their piece of art. It didn't work. You would think that would be a big clue. The thing I just did is causing a problem. Nope. Programmer, fix it. That's what I mean. Patience, zen, calm. This will wash over me. Another one that was funny, Leonard and I even talked about this on our stream, so I will name it because he did it. I didn't put go-tos in the script language I created for Arcanum. Go-tos are the devil's plaything, and I know that a lot of our scripters would not be trained programmers, and I wanted things to be easy for them, so I gave them all the for loops they wanted, but the for loop was written in such a way that it had a beginning and an end. The script would also, there was no way of putting in conditionals that would force a loop that would never end. I thought I had it mastered. I should have learned my lesson. Leonard described what he did. I did have to put in a way for scripts to call other scripts because we had if then, but the block for the then and else, there was a limited amount you could do in it. So what they ended up doing was saying, well, if this condition, then call script A, which does a lot of things, or call script B, which does a lot of things. I thought that's really good. It also helps them partition their work, and maybe script A and script B can be used by other scripts. Great, right? No. One of the first things Leonard did, he had script A call script B, but then script B could call script A. And it would loop, and the stack would blow, and the game would explode, and he would come, there's something wrong. And when I pointed out, it's this script you wrote, this is the one doing it. Haha, we had a big laugh. And the first thing I did was I put in a script limiter. I originally tried to do it by counting those things, but then they found ways of, script A would call B, which would call C, which would call back to A, or call back to B, and then back to A. So I finally just put in, if a script runs more than a certain number of milliseconds, it got cut off, and a warning message got printed. So, of course, that meant new bugs were introduced because a script that got called never finished. It didn't complete what it was supposed to set up, so there'd be an incomplete state. But at least there'd be something in the log going, this script didn't finish running. You may be suffering from an incomplete state. So at least the programmer could point to that and go, this is your problem. Even more recently at Obsidian, When I first started there was a problem where there was a level in South Park that got very, very, very slow. We're talking the frame rate dropped from 30 frames a second to maybe 2. Of course, a scripter came to me and said, "You got to fix this. We don't know what's going wrong." When I looked at it, there was a different scripter, not the one who came to me, who every tick of the game, he grabbed every object in the game, tried to look up a property on that object, and then based on that property decided to do something. Every tick. That was the source of the slowdown. I suggested several solutions, which included when the level first loaded, go through all the objects, find the ones with the properties you want, and cache them. Or it turns out the property was something that we already had a search for object with. We had like search for object named this, search for object of this type. We already had sub-searchers which were way more optimized because instead of happening in scripts, they happened in code. And a lot of them when we loaded them in, we already put them into these categories. So we already had lists available of like, here's every object of this type. I suggested those. They switched. It turns out they were looking for something with a particular name. So not only could it be cached, there was already a function, look for objects of this name. Boom, we're back up to 30 frames a second. The interesting thing about that was like, well, how was this not noticed? The moment that script was written and that level was run, the frame rate dropped. I would expect the person to go, I wonder if the thing I just did, which was the only change from it running at 30 frames a second to running at 2 frames a second, caused it. There is this thing that a lot of other developers learn, a lot of non-program developers, which as soon as there's a problem, just go get a programmer. Because programmers have lots of tools and they can find the exact problem really quickly. But what this means is as a programmer, you're frequently interrupted. And I know everybody hates getting interrupted in their work, but sometimes you're coding something and in your head, you've got this data structure and algorithm that's all set up and you're coding it and you're thinking of like, okay, I have to do this if, but I need to check for this thing. And then I have to do this in the else conditional and I've got to do this. And then somebody walks in and goes, hey, can I ask you a question? And that structure in your head just goes, poof. And so I find a lot of people are like, programmers can be so, they hate when you ask them questions. No, we don't. It's sometimes really hard to get complex algorithms written when you're literally being interrupted every 15 or 20 minutes. This is why a lot of programmers shut the doors to their offices, why they want offices and not large open plan offices, why they use headphones, why they set up office hours and quiet times. It's not because they don't like you. It's just, it's very, very hard to code when you get interrupted. I find that my tolerance for interruptions while designing is much higher than my tolerance for interrupting by coding. And that's me. That's the same person. So depending on what I'm doing, I either like don't mind getting interrupted or I'm like, you have interrupted my code, which would have been a flawless diamond, may now have a bug in it, which happened a few times in my career. I actually wrote code that had a bug in it. I'm glad you were sitting down when you were watching this because I know that may come as a shock. So that's why sometimes when I interview programmers and I'm asking them questions about their education, about their programming abilities, I give them tests to watch them do it on the whiteboard. Sometimes I'm looking at what they're doing. And I'd say usually, if they're talking to them, I'm paying attention to what they're doing. But sometimes I'm paying attention to how they handle me asking questions about what they're doing. Because unbeknownst to them, I was looking to see how patient they were in the meeting. Even if that meant later, I would see things like, well, Tim asked some really dumb questions. He interrupted me a lot. There was a goal. I had a goal in mind. I wanted to know what you would be like when you were on this team and you were going to get questions from non-programmers. I wanted to see how you would react to them. And I always assumed I would get reacted to the best since I was going to be your boss. But I had people get snippy with me in programmer interviews. And I thought, I can only imagine what this person would do if a peer or someone they viewed as less than a peer asked them a question. So sometimes if you look back on an interview and you're like, why was I asked that? You sometimes have to look for a different context. I wasn't digging around for your programming information. I was trying to figure out what you would be like working with. And that's true. I had different questions for designers. I never directly hired an artist, but they have different questions for artists too. You work in a group. The era of single person games, except for very narrowly scoped indie games, is gone. So I look for patient programmers, and I think that's important.